Yes. In this module, we are going to discuss about the mathematical induction and the recursive definitions. Okay. It is the first chapter in this module. Okay. From this first chapter, you are getting one or two questions. Out of 20 questions, you are getting 8 to 12 marks from this chapter. That is a mathematical induction and the recursive definitions. Okay. After that, we are going to study about the some of the fundamental principles of counting. In that, we are going to study rules of sum and product. Okay. After permutations, combinations, binomial theorem, multinomial theorems, and the combinations with repetitions. Okay. From this chapter, this is the second chapter. Okay. From this chapter, we are getting around here also 12 to 8 marks. Okay. From this first chapter, one question is compulsory. From this also, one question is compulsory. Remaining one question, either he may ask from this first chapter or he may ask from this second chapter. Okay. I hope that you know about something information about this mathematical induction. Okay. This was there in the second PUC. Okay. Mathematical induction. Okay. We'll start with this concept only. Okay. Just I am going to give the some basic information about this one. Directly I am going to start with the examples only. Okay. In that you will have the cleared idea. Okay. In that you will have a clear idea, so that I am going to directly start with the example. Just you see here, mathematical induction. The method of mathematical induction is based on a principle called induction principle. This principle is based on another principle known as a well ordering principle. Okay. Here you see we are going to solve okay, some mathematical statement with the help of the induction principle. Okay. How to solve? Here you see induction principle. That is a mathematical induction principle of mathematical induction. Okay. In that, first we are going to assume that given statement. Okay. Given statement, that is a S of n. We are going to take the given statement as a S of n. Okay. Denote an open statement that involves positive integer n. Suppose that the following conditions hold. Okay. We are going to assume that the given statement, that is a S of n. Okay. That S of n has to satisfy the following conditions. Okay. The first condition is this is true for S of n is equal to 1 or S of 1. The given statement should be true for S of n or S of n is equal to 1. Okay. And the second statement is what here? We are going to change what? S of n to S of k. We are going to replace the value n by k here. We are going to replace n by k. Okay. After that, we are going to increment okay the value of k by k plus 1. Okay. First, we are going to replace n by k. Here, initially it was S of n. No. Okay. In the first step, we have checked it for the some condition. What he has given condition, with that we are going to check it. For example, S of 1. The given statement should be true for S of 1. If he has given S of n is equal to 1. If he has given n is equal to 1, then we are going to check the S of n with n is equal to 1. Okay. Then in the second step, we are going to replace n by k. In the second step, we are going to replace n by k. Okay. After that, we are going to check the same expression whether it is true for n equal to k plus 1. Whether it is true for n equal to k plus 1. First, we are going to replace n by k. Then we are going to change k by k plus 1. Okay. Okay. We are going to solve the expression by using the mathematical induction process. Okay. With these two steps. Okay. First one, we have to write basic step. Okay, in that we are going to verify that s of n is true for n is equal to 1. Sometimes he is going to change the condition. Here he is going to change the condition n equal to 6, n equal to 5. Okay, for example, you take here, this is a basic step here, verify that, or we are going to check that whether s of n is true for n equal to 1. Okay, then in the second step is induction step. Second step is induction step. Okay, in this we are going to check that. Okay, assume we are going to assume that s of k is true. S of k is true. Okay, where k is more than or equal to 1, show that s of k plus 1 is true. The meaning is here we are going to replace n. Initially it was s of n. Okay, in the basic step. In the induction step, what we have done, we have replaced n by k here, s of k. Now it is s of k. Okay, after that we are going to check the whole expression whether it is true for s of k plus 1 or not. If it is true, then finally we are going to write the given statement is true for true, where we have proved by mathematical induction. We have proved by mathematical induction. Okay, we have given some of the information here. Directly I will go with the examples. Okay, then we will have the clear idea about this one. Then we will have the clear idea. Okay, here you see. Okay, this is the first example here. The question is proved by mathematical induction. MI means prove by mathematical induction that for all n is more than or equal to 1. He has given some condition. Okay, with this condition we are going to prove this mathematical expression. Okay, this LHS should be equal to the RHS. We are going to show that the LHS should be equal to RHS. Then we have proved the given expression by the mathematical induction. Okay. Just wait, some people are facing network problem. Yes, prove by mathematical induction. Okay, for all n is more than or equal to 1, this is a condition. Okay, and given expression is what here, 1 plus 2 plus 3 plus so on plus n is equal to 1 by 2 n into n plus 1. Okay, this is the question here. Okay, in this we are going to show the LHS is equal to RHS. The LHS is equal to RHS. The condition what he has given, n is more than or equal to 1. N is more than or equal to 1, so that initial the value of n is equal to 1. Yes or no, n is more than or equal to 1 is there, so the initial value of the n is 1, so that we are going to verify. First is solution. Let s of n is 1 plus 2 plus 3 plus so on n is equal to 1 by 2 n into n plus 1. Okay, I have taken s of n is this expression. I have taken s of n is this expression. Okay, this is a given data. Okay, after that we know there are two steps are there here. One is the basic step, second one is the induction step here. Okay, in the basic step what we have to show, okay, in the basic step is s of n is the statement. Okay, s of 1 is the statement. We are going to replace the value of n by 1 here in the given statement here. Where the n is there now, in that we are going to replace n by 1. N by 1. Okay, here you see this is n is equal to 1 by 2 n into n plus 1 now. So that in place of n we are going to put n equal to 1 here. S of n is the s of 1. Why we are going to put 1 only? Okay, but because the initial value of n is equal to 1. Yes or no, n is more than or equal to 1. Yes, n is equal to 1, 2, 3, 4 and so on. So we are going to check with the initial value n equal to 1. Okay, put the value of n is equal to 1 in the given expression. What is that here? 1 plus 2 plus 3 plus 4 plus and so on plus n is equal to 1 by 2 n into n plus 1. Okay, so that here you see n. Yes or no? This is what here? N into n is equal to 1 by 2 n into n plus 1. In this one we are going to put n equal to 1, so that here n is there, here 1 is there. 1 is equal to 1 by 2 into 1 into 2. 1 into 2 means 1 plus 1 is equal to 2, 2 into 1 into 1 by 2. So that when you put the value of n is equal to 1, then we have got this one. To simplify this one, what we will get here? 1 is equal to 1 only, no? This and this 2 and this 2 will get cancelled out each other, so that LHS 1 is equal to RHS 1, which is true. Yes or no? 1 is equal to 1, it is true, no? So thus the given statement S of n is verified for n is equal to 1. So that given statement, this is what here, this is a given statement. Let this statement is verified, okay, with a value n is equal to 1. Yes or no? In place of n we have put n equal to 1 and we have simplified and we have got 1 is equal to 1. Yes, 1 equal to 1 is true. Then the given statement S of n is verified for n is equal to 1. Verified for n equal to 1. Yes sir, this is a basic step. Okay, second step is induction step. Okay, second step is the induction step. Okay, here you see induction step. I told you that assume that S of n is true for n is equal to k. Okay, we are going to make an assumption that, okay, initially we have taken let S of n, no? Okay, assume that S of n is true for n is equal to take n is equal to k. In place of n we are writing k here, that's it. Okay, where k is more than or equal to 1. Initially n is more than or equal to 1 is there. Now we have replaced n by k, so that the given thing will be what here? This is the S of k is equal to 1 plus 2 plus 3 plus so on k is equal to 1 by k into k plus 1 for k is more than or equal to 1. Just we have replaced in n by k here. Everything I have written same here. Okay, this is the initial process in the induction step. Okay, after that we are going to add k plus 1. After that we are going to add k by k plus 1. K by k plus 1. Okay, here you see, assume that this is what here, it is true. Assume that S of k is equal to 1 plus 2 plus 3 plus k is equal to 1 by 2 k into k plus 1 is true. Okay, adding k plus 1 to both sides we get. Okay, we are going to add k plus 1 to the both sides. Okay, how to add here? Okay, here we see in the LHS. Okay, you see what how I am showing on the screen now. You see here 1 plus 2 plus 3 plus so on k is there. To this I am going to add, I am going to replace k by k plus 1. Okay, you just put in place of k by k plus 1, what will be there? K plus 1 only, no? Here k is there. Okay, you put k by k plus 1, k plus 1, so that I am adding k plus 1 to this one, so that 1 plus 2 plus 3 plus so on plus k is there. Okay, in this k is there. To this I am adding k plus 1. To this I am adding k plus 1. Correct? Okay, to the LHS. To the LHS. Okay, to the LHS I have first you how to know what to add. In place of k I have to replace k plus 1, no? K plus 1 it will be there here. So that to this I am going to add k plus 1 like this to the LHS. Okay, when you adding k plus 1 to the LHS, in order to balance the expression, in order to balance this whole expression, I need to add the same k plus 1 to the RHS. The same k plus 1 to the RHS. Okay, initially this is balanced. Okay, I have added k plus 1 to the LHS. Okay, so in order to balance the expression, we need to add k plus 1 to the RHS. We need to add k plus 1 to the RHS. Here you see, this is the the previous one, no? K 1 by 2, K into K plus 1. For this, I am going to add K plus 1 to the RHS plus K plus 1. Now, the equation or expression is balanced. Now, the expression is balanced. Okay, after this one, we have to simplify this expression. After this one, we have to simplify the right hand side expression. Okay, how to simplify? Yeah, as usual, the mathematical process. Okay, here you see in this expression, K plus 1 is common here. 1 by 2 K into K plus 1 plus K plus 1. In these two, K plus 1 will be the common. Okay, so that 1 by 2 K, okay, 1 by 2 K plus 1, and in these two K plus 1 is common out here. K plus 1 I have taken common out, and 1 by 2 remaining is K into remaining. Yes, okay. uh, I have taken 1 by 2 also common, no? So that 2 is going to multiply with this 2. Yes or no? The 2 is going to multiply with this K plus 1, so that here 2 will be there here. Okay. If you taken 1 by 2 in, if you taken 1 by 2 K plus 1 common, the remaining will be K into 2. The remaining will be K into 2, so that the after simplification we will get 1 by 2 into K plus 1 into K plus 2. Okay, after simplification we will get 1 by 2 into K plus 1 into K plus 2. Okay, so that this is the statement, that is S of K plus 1. Yes or no? Okay, this is my result. This is the final result. After simplification we have got this one. This is the final result. How we come to know that this is the final result? How we come to know that this is the final result? Okay, just to see here, after simplification we have to get this one. How we have to come? This is here 1 by 2 K into K plus 1 is here, no? In this one, just to replace K by K plus 1. 1 by 2 is there, yes, 1 by 2. K by K plus 1 means K plus 1. Here K by K plus 1 is K plus 1 is K plus 2. So that 1 by 2 into K plus 1 into K plus 2. So that in this way we are going to know that what will be the final result. In this way we are going to know that what will be the final result after simplification. Yes sir, we have got same thing now here. 1 by 2 into K plus 1, sorry, 1 by 2 K plus 1 into K plus 2 after simplification. Okay, so that this is the statement, that is S of K plus 1. Thus S of K plus 1 is true. Okay, for K is more than or equal to 1. Hence, by mathematical induction, S of n is true for all n is more than or equal to 1. Hence, that is by mathematical induction, S of n is true for all n is more than or equal to 1. Okay. You see here, once again I will explain. This is the given statement here. Okay, we have to show the prove the given statement with the mathematical induction. Okay, first we have to take, let S of n is 1 plus 2 plus 3 plus so on plus n is equal to 1 by 2 n into n plus 1. Okay, after that we have to show that S of n is the statement, or S of 1 is the statement. Okay, because we are going to take n is equal to 1, because he has given n is more than or equal to 1. Initial value of the n is 1, so that I am going to move with the initial value of n is equal to 1 here. Okay, put the value of 1 in place of n, so that we have got this one. So LHS is equal to RHS, which is true. Thus the statement S of n is true for n is equal to 1. Second step is induction step. In that we are going to replace n by k here, so that here you see n by k means after we replace n by k we have got this one. S of k is equal to 1 plus 2 plus 3 plus so on k is equal to 1 by 2 into k plus 1, which is true. Okay, after this we are going to add k plus 1 to LHS and what we have added at LHS, no, the same we are going to add at RHS here. Okay, here you see k is there. Okay, only k is there. In place of k, I am going to, in place of, here only k is there, k by k plus 1. To this I am going to add k plus 1. Here you see 1 plus 2 plus 3 plus so on k plus k plus 1. Okay, to the LHS we have added k plus 1. So there, to balance the expression to the RHS, again I am going to add k plus 1 plus k plus 1. Okay, after this we have to simplify this one. Okay, until we get this result. Until we get this result. How we come to know that this will be the result? Okay, just to see here, just to see the given thing, 1 by 2 k into k plus 1 is there. No, in place of k you put k plus 1, so that 1 into 1 by 2 into k plus 1. Here k plus 1 is k plus 2, so that the whole will be 1 by 2 k plus 1 into k plus 2. So that we have got no here 1 by 2 into k plus 1 into k plus 2. In this way we are going to get the result. So that at the end we have, this is the statement of S of, or else you can write S of k plus 1 is true. Directly right, you can write S of k plus 1 is true. And finally we are going to conclude the statement. Okay, hence by mathematical induction S of n is true for n is more than or equal to 1. N is more than or equal to 1. Just wait for a while.